Alright, so let's try some practice on some things. First thing is, what is the appropriate name for the following? And we can use our nomenclature guide to work through this. And so in our first one right here, we need to identify what is the cation and what is the anion. And so that the cation is always on the front, and so this Na2 is going to be part of the cation, and we know that the CO3 is going to be the anion. And so once we've got that, let's go on through what we've got here. So the first one, part 1 on your nomenclature guide, says if the cation is a metal, go to number 5. Well, we look for sodium. Sodium is way over on the left side of the periodic table, so it is a metal. We go to 5. It says the metal has only one common valence or oxidation state. The first name is the name of the metal. And so sodium is only +1. And so that means we can just go ahead and say that we know this is just going to be +1 right up here. And so once we've got that, we can just go on to the next part. Now we're going to name the anion, and we're on 14, but that streak goes to 15. It says if the anion portion is polyatomic, more than one element, go to 19. CO3. CO3 is definitely polyatomic. It has both carbons and oxygens there. Now, so then we're going to go to 19. It says, is this oxygen stabilized? Yes, it is. It's got those oxygens on the end. And so we go on to 21, it says. And so the most common ones end in 8. And so let's look on our polyatomic ion sheet. Is CO3 there? Yes, it is. CO3 is there. It's carbonate. And so in this case, our first part of this we said was Na is just sodium. So we say sodium right here. Our last part of this is carbonate, because that is the one on the polyatomic ion sheet. So our name is going to be sodium carbonate. That's what this first one is. Let's take a look at the second one, LiBr. Going back through, our first thing is let's identify what cation and anion are. Cation's lithium, anion is going to be bromine, and so we've got those two set up. Now to do this is that we say, is lithium a metal? Far left side, it's on the left side of the stair-step line, so it is a metal. We look at its valence, it says only +1, so that's all it is. And so since it's just +1 there, that's all number 5. The first name is the name of the metal. We can just go ahead and start off just by saying that what we have here is just lithium is the first part. So lithium is the first part of the name. The second part is Br, and so that flips us over to the back. So on 15 it says, is it polyatomic? Nope, it's just bromine. So we go on to 16. If the anion is composed of only one element, the second name of the compound is formed by changing the ending to "ide." So we go and we have bromine, but instead of having the "ene," we drop the "ene" and add "ide." So our answer here is lithium bromide. That's what we've got for that. Our next one, MgSO3. First thing, identify cations and anions. Cations on the front, so Mg is your cation. SO3 is on the back, so that's going to be your anion. So Mg, is it a metal? Is the first question it asks on the nomenclature guide. And we look for magnesium. It's element number 12, and so the answer is yes, it is. Is it multivalent? Is our next question, and it is not. It's just +2, which means the name is just the name of the element. So if we start off here with just magnesium, like that. Okay. The next part is SO3, so we go on to the back for our anion, and that's, is it polyatomic? Yep, we got sulfurs and oxygens. And so we go on to 19, is it oxygen stabilized? SO3, so yes it is. So go to 21. And so the most common form is the 8 form. We look on the polyatomic ion sheet. Is there an SO3? No, there's not. There's an SO4, but not an SO3. SO4 is sulfate. Well, this is a similar form, but it isn't the same as the one on the sheet, so we go into 22. Does it contain one more oxygen in the 8 form? Well, the 8 form's SO4. One more would be SO5. That's not this. 23. Does it have one less oxygen in the 8 form? SO4, drop 1, would be SO3. Yes, it does. And if that's the case, we change the ending from 8 to ite, so instead of sulfate, we have sulfite, and so this would be magnesium sulfite, just like that. And our last one that we've got here, FeOH2. So let's break this down into our cations and anions. Cation is Fe, anion is OH2, just like that. And so in this case, when looking at this, we say that the first part is Fe. Is it a metal? Yes, it is. We go to 5. Is it multivalent? We look at Fe and that +2 +3. Yes, it is multivalent. But the question is, which one? Well, we don't know. So for right now, to start with, we just have a question mark there. We can't answer this until we figure that out. To do that, we've got to look at the back side of what we've got, at the anion. The anion is OH. So looking at that, is it polyatomic? Yes, it is. It's OH. Is it oxygen stabilized? It has an oxygen in it, but actually this is not an oxygen stabilized one because of the fact that the oxygen is on the front side, not the back side. It's not HO, it's OH. That sort of gives you a hint. And so we go on from that one to number 20. It says there are very few. They don't fit the naming rules normally. We just look it up on the sheet, and we do see there is an OH there. OH is hydroxide. And so we can say just right off the bat here, we know the ending part of this is going to be hydroxide. But more importantly than that, we also know that the charge of hydroxide is -1. It says that on your polyatomic ion sheet. And since we have 2 of them, that gives a total charge of -2. To make this balance, that means that the iron has to be iron +2. And so since it's iron +2, that lets us name this. We now can say that this is going to be iron 2 hydroxide, or if you wanted to use the old system, since it's the smaller of the two, then it would be ferrous, because OUS is the smaller one according to what it talks about on the old system section, one number 7 on the front, be ferrous hydroxide. Both are correct. So that's how you go about naming particular compounds. Let's now look at doing the opposite. Find the formula for these particular things. So our first one here is potassium chlorate. And so we start off with potassium here. And so let's look up a couple things. One thing we're going to look up is, let's see what the symbol for potassium is. Symbol for potassium is just K. So we know we got a K involved here. The charge on potassium is +1. So let's write that up here. That's going to tell us how to balance. The next part is chlorate. One thing we should sort of recognize when we see that chlorate is the fact it's got the 8 on the end. If it were just an element by itself, that would be "-ide". H, remember, means polyatomic ion and oxygen stabilized. So we look at our polyatomic ion sheet and we look up chlorate, and we see that chlorate is, I don't remember what chlorate is off the top of my head here. Let's see, chlorate. Do I have that available? Give me just a second here. Okay, so chlorate is ClO3. So ClO3 is what we have for that. And that is going to be ClO3. And that, if you look at that on your polyatomic ion sheet, that has a charge of -1. And so in this case right here, these already balance. And so since they balance, our final formula is just going to be KClO3, since we already have a balanced valence on this. Our next one here is tin-4 oxide. Tin, the symbol for that, if you look it up on the periodic table, you can see the symbol for tin is just SN. We know we've got that there. And even easier, it tells us it's tin-4, which means this has a charge of +4. Don't even have to look it up for that one. The next part here is oxide. It ends in IDE. The IDE ending, remember, is going to generally mean it's an element by itself. And in this case, ox would be oxygen. Oxygen, if we look that up, its negative charge is -2. So to get this to balance, these don't balance just yet. We have to have least common multiple between 4 and 2 is 4. So we'd have to have 2 oxygens to get it to there. And so we put on a 2 right there. And this gives us our final result, SnO2, just like that. Our next one is magnesium hypoiodite. And so magnesium, we look that up, Mg, it has a charge of +2. And so we can say +2 for this. Mg is the symbol. Hypoiodite, we have an ending on that of ite. That indicates that what we've got here is a polyatomic ion and one that's reduced. But it also has a prefix of hypo. And so what we're going to want to do here is, number 1, is just go ahead and look up iodate, because that's going to be the root here. And so if we look up iodate, let's see what we get. we get IO3 minus for that. And so for that guy right there, so we get IO3. The minus indicates it's a -1 charge right there. And so, won't pick up my little thing. There we are. So we have -1. To get these to balance, we have, oops, sorry, made one little mistake here. IO3 is iodate, but in this case we have hypoiodite. And so since we have hypoiodite, that means that the ite part means we lose one, IO2. The hypo means we lose another one, which is be IO. And so to get that to work, we have to get rid of that. That's not what we want. We have IO, because it's lost 2 of its from the iodate, the IO3 that's on your polyatomic ion sheet. Its charge is still -1. Remember, the valences do not change if you change from ate to ite, but we do have to balance this because we're going to have 2 hypoiodites to balance out that +2 on magnesium. And so we have to have 2 of those right there to get it to balance. And so this is what we have. Mg, open parentheses, IO2. And that's going to be magnesium hypoiodide. The next one that we've got here is going to be Fairest Nitride. And so I think I just erased everything else. I'm sorry about that. So for Fairest Nitride, basically what we'd have here is the first part is this ferrous right up here. We're going to have to try to identify exactly what that is. And so for ferrous, we say that doesn't look like any element we're really familiar with, except for the fact we've already seen it a couple times here. But ferrous does look like it would have the symbol of Fe, and so that's going to be iron right here. And so we've got iron as our first one here, but which iron is it? Iron's multivalent. It's +2 or +3. Key here is OUS. OUS means it's the smaller of the two, so this is going to be iron +2. So we've got that here. The next part is nitride. Ending is IDE, which means it's just by itself. So it's just nitrogen, but what's the valence? Nitrogen's that one that's got all sorts of valences, 1 through 5 and 1 through 3 negative, but we said that nitrogen's the one you have to memorize. It's just going to be -3 for that one right there. And so to get these two to balance, that we've got to have least common multiple here is 6, and so we have to get this to work 2 nitrogens, and we have to have 3 irons to get that to work. And so our final result here is Fe3N2. That's ferrous nitride.